Hello everybody, in this video we're going to be talking about exponential decay. Exponential decay uses the same equation as growth, except your b will be between 0 and 1. So using that fact, where b is between 0 and 1 if you're decaying, and it's greater than 1 if you're growing, and b is the number that gets raised to a power, we should be able to just look at this parentheses part and tell whether something is going to grow or decay. What's in the parentheses is the b, and if b is between 0 and 1, that means it's decay. So question 1, it's a 4, it's growth. Question 2, it's 0.87, that's less than 1, decay. 1/5, that's less than 1, decay. 3, growth. When you have exponential decay, the graph is similar, but instead of going to the right and getting larger, now when you go to the right, as x increases, the y's will get closer to a certain smallest value. So we still have a horizontal asymptote, which means we're getting close to a certain y value that we can't be smaller than. The easiest way to find the horizontal asymptote is to look towards the end behavior, which means as x gets closer to a large number, what does y get to? What does y get close to? In this situation, we're multiplying by a half. 1/2 is the decay factor, so that means every single time you plug in an x, you're going to multiply by 1/2 another time. So as you do that, we have this graph here that shows the more times we multiply by 1/2, we're just going to keep on shrinking because we're getting half as large and half as large and half as large. And so for y equals 1/2 x, y equals 1/2 to the power of x. As x gets close to infinity, all these 1/2s are going to get really close to 0. So the horizontal asymptote is going to be at y equals 0. For y equals 1/2 x plus 3, this part matches this thing. For the 1/2 to the power of x, that's the same thing as what we just had in the last question. When x is getting larger, this thing gets close to 0. So in the second question, the horizontal asymptote is just going to be at 3. And they show you a graph of that over here on the right. The 1/2 to the power of x part kind of just goes away, and then the only thing that's going to be left is going to be this number 3 in the end. A horizontal asymptote at y equals 3. The fraction stayed the same, 1/2 to the power of x, so this means as x it gets closer to infinity, you get farther to the right, this fraction is going to get closer to 0, and then when this fraction goes to 0, you can kind of ignore it, and we'll only have the number 5 left over. So we say the horizontal asymptote is at y equals 5. Let's use that idea for these next examples. Y equals 2 times 0.5 to the power of x minus 1. What would 0.5 be as a fraction? It'd be 1/2. 2 times 1/2 to the power of x minus 1. Based off the last example, when you have 1/2 to the power of x, the farther you get to the right of the graph, as x gets larger, infinitely large, it's going to get closer, the y will get closer to 0. As x gets closer to infinity, 1/2 to the power of x gets closer to 0. So in this example, you can think of it as 2 times 0 minus 1, which will just leave you with minus 1. So the horizontal asymptote will be at y equals -1. And we can plan ahead and put a little dotted line saying we're not going to cross y equals -1. To get the rest of the points, you'll use a table from Desmos or TI. Alright, looking at our table, -2 goes with 7, -1 goes with 3, 0 goes with 1, 1 goes with 0, 2 goes with -1/2. And once we're at that 1/2, I would bet that 3 is going to go to -1/4, -3/4. Okay, that's because it's going down. So it's going to keep decreasing closer to -1, but never reach that -1. Alright, now let's do that second one. Starting it off, we got this 1/5 to the power of x. That means we're going to repeatedly do 1/5 times 1/5 times 1/5. Every single time we plug in a new x, we're going to multiply by another 1/5. So then as we go to the right, we're going to increase the 1/5 that we're multiplying together. And then when we do that, all these values, the more 1/5 we multiply, it should get closer to 0. Because when we multiply all those fractions, you're going to multiply the top a whole bunch of times, and all those 1s are just going to multiply to make 1, and the bottom is going to be something that gets close to infinity, and it's going to end up being 1 divided by infinity. Or it's going to get closer and closer to 1 divided by infinity, and that is how we get this approaches 0. So this part is just going to go away, and the only thing that will be left is the plus 5. So as x gets closer to infinity, the y should get closer to 5 in this second graph. Let's verify that by plugging it into Desmos. Then we'll turn it into a table. -2 with +30, -1 with 10, 0, 6, 1 is barely above 5, 2 is even closer to 5, and then the last number we have that's on our graph would be 5, so let's just check that. 5 is even closer to 5. So what's that showing us is that as x gets farther to the right, this part here is getting smaller and smaller. This gets smaller and it approaches 0, like I said before. So much that it doesn't affect the graph at all. The 1/5 to the power of x is going to stop affecting the graph, and the only thing that will be left is the constant. And the horizontal asymptote was at y equals 5. Easy enough. Now let's make a slight modification to our earlier equation. If we're supposed to decrease by r, then this decay factor is going to be b equals 1 minus r. R is whatever percent you're decreasing by. So for example, let's do, if it was a 36% off coupon, then you could do 1 minus 36%, which equals 1 minus 0.36, which equals 0.64. So if you're doing a 34% off coupon, you could just use a B value of 0.64 and multiply by 0.64 to your original price, and hopefully one of these questions will use something like that. Now let's do this first question. If we know the cost, then this is the start. We're supposed to depreciate by 20% each year. This is the R. We need to convert the R into the B. B is 1 minus R, which is 1 minus 20%, which is 1 minus 0.2, which is 0.8. We're supposed to do it over 6 years. 6 years is the period. And let's just make sure that R is also using per year. Yes, it is. So we're just going to have to plug in 6 for X. We'll use our equation, y equals a times b to the power of x. And then when we plug in our numbers, we'll get 11,800 times 0.8 to the power of 6. $3,093.29. It's going to round up to 30. After 6 years. Let's see how many more examples we can do in the next 4 minutes. Okay, we got a tree. It's 3 feet tall. That's a start. So that means that is the A value. I might have skipped that part in the last example. It's growing by 8% each year. That is the R value. If the R is 8% and we're growing, then we're not shrinking. So that means we are supposed to do an exponential growth, which means 1 plus 8%. 1 plus 0.08 to get 1.08 for B. We want to find how tall it'll be after 14 years. So we'll do y equals A times B to the power of x. We're measuring by the years, and both of our units match up for the years. So we can do y equals 3 times 1.08 to the power of 14, and then type this in a Desmos. You'll notice that every time I type this in a Desmos, I always put a parentheses around the number that's going to get the exponent. I think that's the best way to do it. If you want to make sure that the order of operations work, you should always add extra parentheses around the things you want exponents to apply to. Looking at that, we got 8.8115. It wants the nearest hundredth, so that means we're going to stop rounding after the second decimal point. So we get y equals 8.81 feet after 14 years. Next one. We got a motorcycle. It's $9,000 today. It's going to be worth less. Let me change colors. It's going to lower in value. It's 9,000 now, so that's the A value. We'll lower our price by 6% each year. So let's convert that 6% into B. Since we're supposed to lose our value, we're going to do 1 minus, and then I'm just going to convert that to save some space as a decimal. 6% is 0.06, so then B is going to be 0.06 less than 1, which is 0.94. And then we're going to check back after 5 years, so that means x equals 5. Let's use our formula, y equals a times b to the power of x, to get y equals 9,000 times 0.94 to the power of 5. Put it in our calculator. And we'll get that after 5 years, it'll be worth $6,605 and 14 cents. Okay, we got the price of the home. That's the starting value, 2%. It's appreciating, so this means it's growing. And then how much will it be worth in 10 years? That'll be a y equals 126,000, because that's the starting value. If R is growing by 2% each year, then that means the B will be 1.02, because we should be adding on 0.02 each year. And then we'll put a power of 10. You'll type that in the calculator and you'll get your value. Hopefully with this practice, you'll see that these questions are not that difficult. So go ahead and complete your own practice page and turn it in at the end of the class.